Let us learn about some more ways to show that a matrix is orthogonal. So suppose we have a matrix like this over here given at the bottom of the slide, that the matrix A is equal to minus 1 by 3, 2 by 3, 2 by 3, 2 by 3, minus 1 by 3, 2 by 3, 2 by 3, 2 by 3, minus 1 by 3. Okay, so we have to show that this is orthogonal. So one way is that we can prove A transpose is equal to identity matrix, which is equal to A transpose A. If we are able to prove this, then it will be orthogonal. This is the way which we had already learnt in the previous lecture. Just before this, just prior to this lecture, that is lecture number 41. We had learned this particular method to show that a matrix is orthogonal. But now we are going to show some other method that a matrix is orthogonal. So how to prove that a matrix given by this is orthogonal in some other way, not in that way, not in this particular way, but in other way. So what is the method? Let us have a look. So row number 1 is like this, row number 2 is like this, row number 3 is like this. So this is row 1, this is row 2, this is row 3. Now let us take the squares of each of the element of row 1 and add them. So minus 1 by 3 square plus 2 by 3 square, 1 by minus 1 by 3 from here we have taken here, and its square we have taken, okay. Then 2 by 3 over here we have taken its square over here, 2 by 3 over here we have taken its square over here. So 1 by 9 plus 4 by 9 plus 4 by 9, that is equal to 1, okay. So row 1's, each of the elements of row 1 when squared and added, it gives 1. Now let us look at row number 2. So 2 by 3, so 2 by 3 square, plus minus 1 by 3, so minus 1 by 3 square, plus 2 by 3, so plus 2 by 3 square, okay. And after addition, 4 by 9 plus 1 by 9 plus 4 by 9, it gives 1 again, okay. It again gives 1. Then the last one, row number 3, okay. This is row number 3. I don't know, some problem is there. Just a second, guys. Okay, okay, now it is okay. There was some problem, okay. So row number 3. So this is row number 3. Let us have a look at row number 3. The same thing, the things which we did for row number 1 and row number 2, we are going to do the same thing for row number 3 as well. Okay, so 2 by 3 square, so 2 by 3 square. Okay, 2 by 3 square, so 2 by 3 square. Minus 1 by 3 square plus minus 1 by 3 square. So 4 by 9 plus 4 by 9 plus 1 by 9 equal to 1. Okay, because 4 plus 4 8 and 1 9, so 9 by 9, that will be equal to 1. So the first property of an orthogonal matrix, the very first property of an orthogonal matrix is that when you square the elements of an orthogonal matrix, one row at a time, okay. So if you take this element is square, this element is square, and this element is square from row 1, it should be 1. Okay, so every row should satisfy this particular condition. Okay, that is the sum of the square of elements. Sum of the squares of elements should come out to be equal to 1 for each row. For each row, the sum of the square of elements should come out to be equal to 1. Now, let us learn about the second property of an orthogonal matrix. What is the second property of an orthogonal matrix? So the second property is that row 1 and row 2, when you take the products of these elements, this element plus this element multiplied by this element plus this element multiplied by this element, that should be equal to 0. Then this element multiplied by this element plus this element multiplied by this element plus this element multiplied by this element should be equal to 0. Okay, this element multiplied by this element, okay, plus this element multiplied by this element plus this element multiplied by this element, its sum should come out to be equal to 0. So let us have a look at let us take row 1 and row 2 first. So minus 1 by 3 multiplied by 2 by 3, minus 1 by 3 multiplied by 2 by 3. Okay, 2 by 3 multiplied by minus 1 by 3. So 2 by 3 multiplied by minus 1 by 3. And 2 by 3 multiplied by 2 by 3. So 2 by 3 multiplied by 2 by 3. So minus 2 by 9 minus 2 by 9 plus 4 by 9. It is equal to 0. So this came out to be equal to 0. This came out to be equal to 0. Okay. Now let us take row 2 and row 3. Row 2 and row 3. So row 2 and row 3. So 2 by 3 multiplied by 2 by 3, 2 by 3 multiplied by 2 by 3, minus 1 by 3 multiplied by 2 by 3, minus 1 by 3 multiplied by 2 by 3, 2 by 3 multiplied by minus 1 by 3, 2 by 3 multiplied by minus 1 by 3. Okay. So 4 by 9 minus 2 by 9 minus 2 by 9. So this also came out to be equal to what? This also came out to be equal to 0 itself. This also came out to be equal to 0 itself. Now let us take similarly row 1 and row 3. Let us take row 1 and row 3 in a similar fashion. So this element multiplied by this element, so it has been written over here, okay, plus 2 by 3 multiplied by 2 by 3, so it has been written over here, okay, then 2 by 3 multiplied by minus 1 by 3, so 2 by 3 multiplied by minus 1 by 3 has been written over here. Then minus 2 by 9 plus 4 by 9 minus 2 by 9, again it is coming out to be equal to 0. This also is coming out to be equal to 0. Okay, so two properties must be satisfied by a orthogonal matrix. So this matrix is an orthogonal matrix, we have successfully proved. Okay, so what is the property which an orthogonal matrix should satisfy? It should satisfy this particular property which has been written over here. The sum of square of each row is equal to 1. Okay, the sum of square of element of each row is 1, already told to you. Okay, so row 1 all elements square, this square plus this square plus this square, row 1 complete, so equal to 1. This element is square, this element is square, this element is square, row 2 complete, so their sum equal to 1. This element is square, this element is square plus this element is square. Okay, row 3 complete, so their sum should be equal to 1, and they are coming out to be equal to 1. So one set condition they are satisfying. And also the sum of product of any two row is equal to 0. Okay, sum of the product of elements of corresponding elements of any two row is equal to 0, that is two rows taken at a time. Two rows taken at a time. So what is the second property that an orthogonal matrix must satisfy? This property, that this multiplied by this plus this multiplied by this plus this multiplied by this should be equal to 0. Okay, so when you take the corresponding elements, this element corresponds to this element, this element corresponds to this element, this element corresponds to this element. When you take their product and you add them, it should come out to be equal to 0. This element corresponds to this element corresponds to this element, and this element corresponds to this element. So their product when you take and when you add, it should come out to be equal to 0. Okay, this element corresponding, they are this element they are corresponding, this element and this element they are also corresponding. So when you take the product and you take the sum, it also comes out to be equal to 0. So also the sum of product of any two row is equal to 0, that is taken two rows at a time. So when this condition is satisfied, which has been written from here till here, this particular condition which has been written from here till here, okay, from here up to here, this condition which has been written, if this condition is satisfied, then the matrix is orthogonal. So A is an orthogonal matrix therefore, because it is satisfying this particular condition. Okay, so from this question onwards we will have a look at it in the next class. From this question onwards we will learn in the next class. Now one end screen will appear over here. Click on the end screen and watch the next video. Thank you very much.